The screen visible to everyone?
Yes, yes.
So today on the topic of mechanics of fiber reinforced polymer composite structure, this is the live session number 5. Myself Vaina Mandal. Today we are going to discuss some sample problems which will be helpful for solving the assignment number 6. So in this module, sir mostly talked about the changes in the composite because of temperature change and the moisture, and the questions in the sample questions are also according to that topic. So the first question is, a unidirectional glass epoxy lamina having 64% fiber volume fraction have the Young's moduli and Poisson's ratio of fiber and matrix given, and also the coefficient of thermal expansion of the fiber and matrix is given. So the relation is already given in the assignments directly, and we have to find the coefficient of longitudinal thermal expansion. Now, even though in the question the equations are given, I would like to go back and talk about little how those equations are found. So for finding the coefficient of longitudinal thermal expansion, we initially it was considered that there is no mechanical load on the composite which consists the lamina, on the composite which consists the fiber and the matrix, and when there is a temperature difference, there is a stress happening on it, which can be equal stress on the fiber can be equal to EF moduli of the fiber and the strain in one direction. But also it, because of very good contact between the matrix and the fibers, there is some restraint on the matrix from its total, which can be uh, which is which can be defined as alpha F delta T E F when the fibers are in the free condition. So when we are considering the stress of the fiber in the composite, we have to subtract it to uh, the stress of the fiber in that direction minus whatever will happen when the fibers are in free state because of the thermal expansion. This whole term is known as the amount of restraint on the fiber and the matrix. Now, from this equation, as initially I said that there is no mechanical load, so total stress on the composite will be zero, which can be which the total load is equal to sigma F Vf plus sigma M Vm, which is equal to 0. Now substituting these values in this equation, we can get the equation of strain in direction 1 in this form in terms of delta T. Now comparing it with the coefficient of thermal expansion of composite along direction 1, we can get the, by equating them, we can get the value of alpha 1 in direction when there is load in direction 1. Similarly, when we want to find the coefficient of thermal expansion in transfer direction, we consider the strain equations in transfer direction for fiber and the matrix, which can be equal, which again by this condition, by what I talk about amount of restraint, you can see we have the strain that will be because of thermal the change in the temperature and the normal strain. Then from these two equations we can put this value in the total strain in direction 2 as eta F2 Vf plus eta M2 in Vf, and equate it to the thermal coefficient expansion composite along the direction 2, and from that we will get alpha 2. So back to the question, here they ask to find the coefficient of longitudinal thermal expansion. Longitudinal is in direction 1. So we will put the values that are already given in the question in this first equation to find the alpha 1, and we will find the answer. The next, the next question, with the same data they are asking the coefficient of transverse thermal expansion, which is alpha 2. So we put all the values in this equation of finding alpha 2, and we will finally get the answer. Now the next question is, the longitudinal transfer coefficient of thermal expansion of a unidirectional carbon epoxy composite with the fiber volume fraction 60% are measured, and we got the value of alpha 1 and alpha 2 is given. Now we have to use the same equations to find the longitudinal transfer coefficient of thermal expansion for the carbon fiber. So it is just using the same equations, and we have to do the back calculation. We are given the value of alpha 1 and alpha 2. We have to find the value of alpha 1f and alpha 2f from this equation, and every other values are given of the matrix and the fiber. So after solving, putting the values in this first equation, we will get the value of alpha 1f, and from the second equation we will get the value of alpha 2f, and that will be the answer. The next question says the composites with zero or near zero coefficient of thermal expansion are desirable in space application where the components experience a wide range of temperature variation, and the properties of the graphite, fiber and epoxy matrix are given. So we have to find the fiber volume fraction at which the longitudinal coefficient of thermal expansion of the unidirectional graphite or epoxy lamina will be zero. It is, they are asked about the longitudinal coefficient of thermal expansion. They said that the longitudinal coefficient of thermal expansion should be zero. That means the alpha 1 value should be zero. Now using this first equation that we have used before, the equation of alpha 1, we take the value of alpha 1 as 0. Other values of the moduli and the volume fraction is given of the fiber and the matrix. Then we put all the values in it, and we can finally get the volume fraction of the fiber at which the alpha 1 will be 0. As Vm we know is equal to 1 minus Vf. So from that we can get the final value of Vf. The next question is, a glass epoxy lamina having 60% fiber volume fraction have the following material properties of fiber and matrix, and these are the following correlations which are used to evaluate the coefficient of moisture for the lamina. Like how it was done for thermal expansion, moisture expansion also, the equations are derived in the same way, and these are the final equations that we can get by after deriving for the coefficients of moisture. Now in this question, the percentage or the concentration of moisture is not given, so final calculation is done in terms of delta Cm only, but in the assignments which are given this time, the percentage of moisture content is given for the lamina. So, and we have to consider delta Cf equal to 0. As sir taught in the class, mostly the moisture absorbed by the fibers is 0. So in this question, they ask to find the value of beta 1 for glass epoxy lamina with 60% fiber volume fraction. So the first equation we will be using, by considering delta Cf equal to 0 and putting all the values that are given in this table, we can find the value of beta 1. The same data has been used here with the same conditions, but here we have to find the value of beta 2. So the second equation as given here, we can get the coefficient of moisture in transfer direction from this equation, and we will put all the values in it, we can get the answer. Now next question, they said that we have to read the following statement. The first statement says that with the decrease in temperature, the gradual softening of the polymer matrix takes place up to glass transition temperature. And the second statement says, with the further increase in temperature beyond the glass transition temperature, the polymer matrix becomes too soft like rubber, which may not be suitable to use as a structural material. As you can see from the graph here, between the stiffness or modulus and the temperature, you can see as the temperature increases, the polymer, this is graph of any polymer, and its matrix is a polymer. So this is we can see as the temperature increase, the stiffness and the modulus decreases of the polymer. Initially it decreases and it is in a glassy state, and then after decrease it reaches a point that is called a glass transition point, and after that it turns into a rubbery state. So what the first statement says, that with decrease in temperature, the gradual softening of the polymer matrix takes place up to glass transition temperature, which is not correct. As you can see, after when the temperature is increased, then there is gradual softening and we reach the glass transition temperature. So the first statement is incorrect. Whereas with further increase in temperature beyond glass transition temperature, polymer matrix becomes too soft like rubber. As you can see, when the temperature is increased after the glass transition temperature, it reaches a rubbery state. So the second statement is correct. So answer will be that statement 1 is false and the statement 2 is true. Now the next question is, any doubts till now?
In that question number 5 and 6,
Hmm.
here that row C, row C is last term in that beta one last term row C.
This one.
That is the density of composite is equal to that density of fiber into volume fraction plus
Density of
density of
matrix.
matrix into volume. Okay. Then this delta CF is there. No? It's always zero. So even if they are not given in the question, the moisture absorbed by fiber is zero. So we have to take zero delta CF always zero.
In the assignments, is it given that delta CF is equal to 0
No, no, madam. In the assignment, he is given that only 50% moisture is absorbed.
by the
So,
lamina?
yeah, by the lamina. So, what we have to take that for delta CF and delta CM there.
In the class, actually, sir taught that delta CF is equal to 0. But it should have been like given in the question itself so that it would have been more clear. Uh,
I think in the next question, check in the next question. Question here also he has given. Yeah, actually,
Delta CF is equal to 0 is given, but in this assignments, I think it is not given. So we can, I am not sure what to consider for the assignment question. It is better you put a question in the discussion to ask for that whether you should take delta CF equal to 0 or not. Because last session also there was one doubt and many people had problems by what answer I said. So it's better you put in discussion what to take the whether you should take delta CF equal to 0 or not, because in class lecture sir actually said the delta CF is mostly 0, but if it's not given in the question, it's better to put a discussion whether you should consider it equal to 0 or not.
okay. Then mu one two. Okay. Okay, okay. So in the as in the assignment question, he has given that 50% of the moisture is absorbed by the lamina. So we have to take delta Cm equal to zero point 0.5 and delta Cf equal to 0.
uh, yes, it should be like that. The delta CF, if we take it equal to 0, then the whole moisture will be taken by the matrix only and we will consider it for CM, delta CM. But it's better that you put in discussion forum this question whether you should take delta CF equal to 0 or not.
Okay, okay.
Okay, so next question. In a unidirectional glass epoxy lamina, beta 1 equal to 0, beta 2 equal to 0.5, and for a delta C equal to 0.005, the material axis strains developed in a free unidirectional glass epoxy lamina are. So we know the strain is directly proportional to the coefficient of moisture expansion and the moisture concentration. So for different strains we have to find the material axis strains developed in the free lamina. So we have to find eta 1, eta 2, and gamma 1, 2 will be equal to 0, as when for a lamina there is no shear strain because of moisture. So we take it as 0, and eta 1 and eta 2 will be equal to directly, as from equation you can see eta I equal to beta into dot C. So in matrix form, eta 1 will be directly equal to beta 1 into delta C, and eta 2 equal to directly equal to beta 2 delta C. From there, delta C is given, beta 1 and beta 2 is given. So we will get the value of the eta 1, eta 2 and gamma 1, 2, which will be equal to 0. And next question is, in a unidirectional glass epoxy lamina, beta 1, beta 2 and delta C are given. The global hygroscopic strains developed in a free 60-degree glass epoxy lamina are. So now here there is an angle given of the lamina on the of the fibers in the lamina. So as in before also we have studied how when there is fibers in certain angles, we have to consider the principle where there is a conversion between principal axis and the global axis. As you can see in the options, they are asking the global hygroscopic strains. That is, we have to find the values in the global axis, and the values which are given of beta 1 and beta 2 are in the principal axis. So again, we will use the transforming matrix. So by multiplying this matrix into the principal axis strains, uh, principal axis coefficients, we can get the coefficients in the global axis: beta x, beta y, and beta xy by 2. Here you know CS is cos theta, sine theta, and theta is given 60 degree. We will solve this matrix into the principal axis coefficients, and we will find the coefficients in the global axis. After finding the coefficients, we can convert it into the strain from the equation that is showed in the last question, eta I equal to beta into C. So delta C is given, beta values in global axis in global axis we got from the principal axis, and then we will get the strain in the global axis, and that will be the final answer. Okay, any doubts? Yes, Vishwas.
In that assignment, last question, I think hygroscopic coefficient one question is there.
In assignment or the sample problem session?
Yeah, in sample problem which you showed in that last but one, you have taken one formula that is hygroscopic coefficient beta equal to. Can you go to that this one?
This one?
No, no, previous to. Here that epsilon I matrix, no, that is the matrix strain.
It is a normal equation. Strain is equal to the coefficient of moisture expansion and the moisture concentration. I took it in the, it is shown in matrix form, but it's a direct equation. So eta 1 equal to beta 1 dot the concentration. It's the normal equation. It shouldn't have to be in a matrix form. It's a direct equation. You can find the strain in direction 1, longitudinal, in transverse by taking the coefficient value in transverse and longitudinal
No,
direction.
not mathematical matrix. No, that composite metal matrix and fiber is is it applicable for only matrix or is material axis? M is material axis, right? Epsilon 1, epsilon 2, gamma 1 to taken, I think it's a material axis.
No.
Yeah, whole lamina. Now my doubt is if the lamina absorbs 0.5% of the moisture, so we have to take that C as 0.5.
If it takes 0.5%, then you have to take it as
0.005. Okay. And beta, if beta is not given, we have to calculate beta.
beta will be given.
No, I think in the question is given only 60-degree angle lamina and he has given only 0.5% moisture. And hygroscopic coefficients means yeah, beta 1, beta 2 we have to find.
What is there in the question? You're talking about the question in the right now assignment you got.
Yeah, 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 yeah. Last question.
So can you tell me the question? Like what all datas are given?
Only two data are given. One is 60-degree angle lamina, and another one is lamina absorbs 0.5% moisture. We have to find hygroscopic coefficients Bx, By, and Bxy.
Oh. And B1 and B2 is not given.
Yeah, that's not good.
B2 you won't be able to find Bx, B1.
Mm,
Okay. Can you put this question as a doubt in the discussion?
yeah, yes.
How to find if it's B1 and beta 1 and beta. Is there any previous question on which the same data is there or nothing?
No, no. This is the separate question.
Put it in the discussion, like about how to do it if beta 1 and beta 2 is not given.
Okay. And ma'am, that previous assignment question, actually, that volume fraction value we have entered, I have entered in percent.
I saw a lot of students said that they're saying it is showing incorrect. So it's been asked to sir whether how to consider it, because most of the places by saying volume fraction they took it in percentage. So I also thought it should be in percentage because the previous questions I have solved it was taken in percentage. But uh,
Yeah, it's just a request if possible. Is it possible to reevaluate only those two questions? If it's in percent also, is it possible to consider it? Reevaluation.
uh, uh, people has
Because in some other subjects,
students have actually asked that question. Let's see if this is sir's decision. So I don't know. And there is a live session will be there in this month also. So maybe it's better you can put on this question when sir will come in.
actually technically if we go, actually previously I had entered it in decimal only. I had not converted it into percentage. After this
Last time also
live,
when we discussed, initially I was also saying that it should be in fraction. But then by solving the questions that I did for sample, it was for fraction also they said in percentage. That's why I got confused. So
no,
sorry
the
about
question
that.
which you solved, it had four options, and the
Yeah,
four
yeah.
options were in
We're in
percentage.
percentage, yes.
So whatever you did is correct, but whatever question we had, we were not having the options. We were supposed to enter the values, and the units he had not mentioned in the question. So there was just a space. So even if we go technically, percentage is the wrong answer because percentage symbol was not there. Whatever space he had not given, but it's just a request.
Let's see, sir will be the one deciding.
Okay.
Lot of students have actually asked sir to consider it. Let's see what sir will do.
Madam, also said wrong, madam. Myself also fifth and seventh questions only wrong due to I am putting answer.
I have seen your comment also.
Yes, madam.
Mm.
Actually, you solved the last session. You say the same answer.
Yes, yes, I know. The question I solved in that for volume fraction, they were taking in percentage. That's why I
Yes,
said
madam.
percentage, but this assignment
Last
question didn't.
class also one participant asked doubt about this how to put the answer in that fill in the blanks question. So you told also percentage is enough.
Yes. I solved for that, but it had options. But for filling NATs, I didn't know what they considered it percentage or fraction. So.
Yes, madam. First I put answer in fraction, but your video after seeing I converted into percentage.
Any other doubts from sample questions? Okay, then we will end this session here. Thank you.